In this tutorial, we're going to walk you through the nesting feature in the software to achieve maximum usage of our available material. We'll take you through several scenarios, each demonstrating different options and which ones work best for the type of job that you may be running. So let's just go over to File, Close. So let's begin by opening an existing file. So from the Nesting Guide project folder, we're going to open the Olympic Stadium file. Okay, so here we have a sign where we have a border and we have all of the letters for the Olympic Stadium sign. And we've been asked to create two lots of these signs where we have one piece of material that is 48 inches by 48 inches. So how do we go about creating two copies of this using the material size that we have here? Well, one way of doing this is we could select all of the vectors. We could right click and then use the option to copy them, in which we can then right click and then paste the vectors and then manually arrange all of the vectors around our sheet. Or we could just let the software do all the hard work for us and we can look at nesting those vectors. So let's just select all of our vectors and we'll take a look at the nesting tool. So the nesting tool can be found at the bottom of the drawing tab under the offset and layout section, and it's this one here where we can use the nesting option. And so by clicking on that, that will open up the nesting form. And so this form allows us to control different settings that we may want to apply when nesting our parts. And the software will highlight what it believes to be parts with this dark outline. So it thinks that this part here is one part, and then each one of these letters is one individual part also. So starting at the top, we need to specify our tool and clearance settings. So first off is the tool diameter. So this needs to be the tool that you're going to use, in which case I'm going to use a 1/4 inch end mill to cut all of my parts out. So I'm going to enter a value of 1/4 inch in here. And this will leave a minimum of 1/4 inch between any of the parts that are cut out. The second option allows us to apply a clearance, so you may want to have a bigger clearance gap between the parts to preserve any cutting finishes that we apply when we come to do the toolpaths, that being either climb or conventional milling. And so if two parts were only 1/4 inch apart, which is the same as the diameter of the tool in our case, when the tool will be cutting out one of the parts, it will also be cutting what would be the finish on another part. So we may want to add in an additional clearance as to not touch the finish of another part, or we may just want additional clearance to add tabs to hold our part in place. And so we can specify an additional clearance onto the tool diameter. Here we'll just put in a clearance of 0.35, so that's 0.1 bigger than our tool. So that way we're going to have a maximum of 0.6 inches between the parts that we are cutting. And this would mean that the minimum gap between any toolpaths that the tools may take, there'll be a minimum gap of 0.1 inch between each of those paths. And that will be built upon two lots of 1/4 inches on the outside. So imagine 1/4 inch on the outside of the O, 1/4 inch on the outside of the L, and then we would have a 0.1 gap in between them, which would build up to the 0.6 inch minimum clearance between the letters. So let's just use this option here to zoom Active View to draw in limits, and we'll just select all of those vectors again. The last option that we have in the tool and clearance settings is the border gap, and this is the margin applied around the edge of our material, which helps with our hold down method not being interrupted. For example, we may want to clamp down or screw the material down into our spoil board, and so we're going to look at applying a border gap there. And so we'll go with 1/2 inch in this case. That should do the job, but you should just check with your own settings. And then we move on to part nesting, where where we have different methods that we can use to arrange the vectors that we have selected to best fit in the space that we have and to efficiently make use of the material that we have. For now, we're not going to go with any of these options, and we'll just see how the software nests the parts using the options below. And so this is where we specify a corner in our job where the software will nest from. At the moment, it will nest from the bottom left-hand corner over here because that's the option that's currently selected. So we're going to leave that there for now. Then you can choose your nest direction, whether you nest along the x-axis or whether you nest along the y-axis. We're going to leave that to nest along x. Then you need to specify the number of copies that you want to create. In this case, we want 2, so we're going to use the up arrow key, or you could simply highlight the value in there and just type in a new value, and you'll go ahead and press apply. And so we can see that the software has now labelled all of the parts with a value in which that value is the number of copies that we require, which is 2, which we put in here. And then we could simply go ahead and press preview. From an initial look at the part, it's not that bad. However, I do have 2 sheets. I can see this one is currently labelled sheet 1, and if I just scroll out here, you can see that I have several letters that couldn't quite fit onto this sheet have been spilt over onto a new sheet of the same size, and I can activate each sheet by double clicking on it. So now we are looking at sheet 2. Another way of doing this is by going to the active sheet. Here we can say 1 to put that back to the first sheet here. Now looking at our part, we can see that the centre of each one of these signs is essentially going to be waste material. So why don't we look at reusing this space for creating more parts, so we can use the internal space of each one of these sign borders to input the overspilt letters to save us eating into another sheet. So here we'll just reset the preview. Let's just use this option here to zoom active view to the drawing limits. So we're going to look at checking this option here to allow parts inside of other parts. And so the software will detect that this area is going to be waste material, and that's indicated by the brown coloured outline. And so the software will make use of this space to fill it with what objects it can. So here we're just going to apply that, and then we'll go ahead and we'll preview that. And there we can see it's put all of the letters inside of each one of these sign frames. And so we have lots more space for other jobs too. Now from the same customer, I have another job that needs cutting out. So let's see if I can combine that with this job to really make use of my material. So just going to reset that preview. I'm just going to close out of the form. So let's just go to our layers bar at the top. See here we've got fast food vector here. So if I just double click on that to select it, I'm just going to take it and we're just going to move it up out the way here. Then we'll just zoom out so that we can see that there. Right then, so now we've got all of the vectors that we need. We can just select everything, and then we can go back into the nesting form, and we're going to go with the exact same settings as before. So number of copies here, we want 2 of those, and then we could go ahead and press apply, and then we could go ahead and then preview that. And there we can see that all of the vectors for 2 jobs are now on the same sheet. And this will make this job more profitable as we're maximising the use of the material that we've purchased to create this job. So now we can look at applying a quick profile toolpath around these vectors, and we can demonstrate the tool diameter and the clearance gap between each of the parts for a better visualization of the tool and the clearance settings. So here we're just going to press OK to accept those changes, and then we're going to switch over to the toolpaths tab. Just use this option here to zoom active view to the drawing limits. And then we could simply select all of the vectors, go into the profile toolpath. Here we're going to cut all the way through those vectors, so put in C equals, select a tool, so we're using that 1/4 inch tool as we mentioned earlier, we're machining on the outside, and then we'll just simply go ahead and press calculate, and then we could preview that toolpath, and then we could even look at deleting the waste material to get a good idea of what those parts will look like. Now what I want to show you here is the gap between the toolpaths and the clearance that's available while cutting. And so to show you that they're not going to be too close, we can have a look in the 2D view. So let's go over to the 2D view. We're going to switch on the visibility of the toolpath. Now at the moment we're currently viewing this using the wireframe toolpath preview, so we can see the arrows, the direction of the toolpath, but we're going to switch over to the solid view. So this solid view just indicates where the tool will actually be cutting away. So anything that's purple will be cut away by our tool. So if we just zoom in over here, we just use the mouse just to zoom in. Okay, so we can see that solid colour represents the tool. So this is our 1/4 inch. We're doing a cutout here, and then here we have a minimum gap of 0.1 of an inch, which is that clearance that we specified, which could be used for tabs or just to keep it out of the way of affecting other finished areas, whereby in this example here we've got that 1/4 inch tool cutting the A out here. Okay, so let's have a look at another example of nesting. So we're just going to close out here. We're also going to close the file. So we're not going to save the file. Now we're going to open an existing file. So here we're going to look at the nesting example, and we'll go ahead and press open. Okay, so here we have the vectors that we want to nest on the right of our job, and we are working with a 48 by 48 sheet. Okay, so I have all of these components and I want to create 25 copies of each of these vectors to put onto our sheet. I'm just going to box select this component here. We're going to go into the nesting tool. So we're going to go the same settings that we did previously. We're just going to uncheck this option to allow parts inside of other parts. And then here we'll specify the number of copies. So we'll go with 25. Press apply, and then we could go ahead and preview that. Okay, so judging by the view here, I can see that we may well have another sheet, and we can see that we have an overspill of 5 components that cannot fit on sheet 1 and so have been put onto sheet 2. So let's just reset this preview, and then we'll just use this option here to zoom active view to the drawing limits, and we're going to look at another way that we can nest these vectors so we can get all of them onto the one sheet. So here we're going to look at the mirror parts to find best fit option, and you'd use this if you weren't too concerned with which side of the part is the top side, as some materials have a finished side and an unfinished side, so you'd have to bear that in mind if you wanted to mirror the parts to best fit the material. So we're going to check on this option here, and then we're going to go ahead and press apply, and then we'll just go ahead and preview that there. Okay, again, judging by what we can see here, it does look like we have an overspill. So we've got 2 parts that have been fitted onto sheet 2. And so the parts have been nested along the x-axis, and then where it's got to the end here, the software can no longer create a new row, and therefore it will try to mirror the parts to fit in the space. So now we're going to look at another option to see if we can better fit our parts into our material. So let's just reset that preview. We're going to uncheck the mirror parts to find best fit option. And then we're going to look at this option here, rotate parts to find best fit. And so it will rotate the vectors in increments of whatever it is that you specify in here to best fit the part. So we're going to check that option here, and we're going to look at rotating that 45 degrees. Now you may need to think about the importance of the direction of the grain when doing this, just in case you wanted all of your parts to have the same grain direction. So let's just go ahead and we'll just apply that, and then we could go ahead now and preview what we've got there. So here we can see that the software has managed to rotate some of the parts in increments of 45 degrees just to get them onto sheet 1. However, we can see straight away here that we do have a second sheet, and we've got 2 parts here that have been overspilt onto the sheet where it couldn't fit onto sheet 1. So what we can do is we could look at reducing the rotational step angle if we wasn't concerned with the grain direction of the material, to see if we can really maximise the material usage. Now if grain direction is not a concern, then we can look at lowering the rotational number to as low as 1 degree increments, and so that it can rotate each of these vectors 360 times using the 1 degree step angle to find the best fit for our sheet. So let's just reset that preview, and then we're going to go over to our rotation step angle, enter 1 in there, we'll press apply, then we'll go ahead and we'll preview that, and you can see that the software has rotated all of the parts and we have all 25 copies on the one sheet. And so there we've demonstrated various ways of really maximising the space that we have available to use. So let's just go ahead and reset this preview. We're just going to look at another example. So let's just cancel out of the nesting form. And then we'll just click into the white space. Now let's imagine that we only had this size material available to us. And now we want to cut these items where we want 5 lots of each one of those. Now as always, to maximise the remaining material, we should use the nesting feature. So with those vectors, let's go over to the nesting feature. We're going to use the same settings that we did previously, and this time we're going to create 5 copies here, and then we're just going to go ahead and press apply, and then we can preview that. And so we can see here that the software has successfully nested the parts to create 5 of each component there. You can see it's rotated quite a lot of them to best fit the space that we're working with, and we still have all of this space left over. Now imagine that we've already ran this job on our machine, and now we want to make use of this remaining space here. So how can we nest further objects into this particular space that's available to us on the right hand side? So let's just OK that, and then we'll come over, and then we're going to look at drawing a rectangle. So we're just going to freehand draw a rectangle that kind of represents the space that we're working with. Okay, so just want to shrink that in. It's overlapping some of our parts there. And so the idea is we want to nest these parts to fit within this side of our material that we've already part cut into because of all of the components on the left hand side. So let's go back into the nesting tool. And so we're going to select the 3 parts, and we want 5 copies of each one of those components. And we have an option in the form where we can use the last vector as the nest boundary. And so if I hold down Shift and select this vector here, and then check that option as the last vector as the nest boundary, it's going to take our parts that we want to nest, and it's going to nest them within the bounds of the last vector that we had selected. And so in which case we could go ahead and press apply, and then we could simply preview that, and you'll see that with these settings here it's going to nest them inside of the rectangle that we had selected. And you can see that we still have space on the right hand side here. And so this just demonstrates how we can plan ahead with the jobs that we're given to really maximise the usage out of every piece of material that we use, resulting in more profits in the long run. Okay, so let's just cancel out here and we're going to close out of this file, and now we're going to look at another example. So we're going to open an existing file. Here we're going to open up the widget file, so we'll open that up. So here we have the Vectric widget, and the part has been set up in such a way where all of the toolpaths are associated with vectors on layers. So you'll see we have an outline shape, we have recessed rectangles, we've got text, and we've got the drill holes. And so using the automatic vector selection option, we can associate specific rules to the toolpath. For example, let's just go into one of these toolpaths. We'll go into the drill holes toolpath. So at the bottom here, you've got the vector selection. We can currently see it's set to automatic. We can see that those vectors are selected when we open up this toolpath. And if we go over to the selector, it will open up the vector selector form where you're able to select the vectors based on various filters and rules that you apply here, whereby you associate it with the toolpath. And there are other tutorials that cover the setup for the automatic vector selection in more detail, and you can find those videos in the related videos section for this tutorial. So let's just close out here. And so each one of these toolpaths is associated to vectors on a particular layer, and I could cut this one on its own as a prototype. So let's just have a look at what our part looks like. So we'll just use the preview all toolpaths option. Okay, so you can see what the widget looks like there. And so having the part set up this way, where we let the software pick the vectors for us by applying various rules, it just means that if at some point in the future I may want to mass produce this part, and I can simply nest the vectors that we have here using the nesting feature, and because the toolpaths are associated with the vectors on the particular layers, all I have to do is simply recalculate all of the toolpaths without having to manually add in copies of the nested vectors to each toolpath. The software will automatically do that for me. So let's have a look at how we can do this. So let's just switch over to the drawing tab. We'll just go back into the 2D view there. So let's just go and change our job size. We'll go into the job setup form. We're going to make this 36 inches and we're going to give that a height of 36 inches, and then we could go ahead and press OK. So we're going to select all of the vectors here and we're going to go into the nesting tool. So we're going to have a 1/4 inch tool diameter here. The clearance, we're going to go with 0.3 in this case, and we're going to have a border gap of 1/4 inch. Okay, we're going to rotate the parts to find the best fit, where we're going to put in a 90-degree angle in there. We're going to nest from the lower left and we're going to nest along the x-axis. So here I want 18 parts, so we're going to go ahead and press apply, and then we'll just simply go ahead and press preview. Okay, so you can see our parts and we can see we do have one left over. So let's have a look and see if we can maybe reduce the angle. So here, let's just set that to 30 degrees in this instance. We're just going to reset that preview. With that 30, we're going to apply it, and then we're going to go ahead and preview that. We can see that everything now fits on the one sheet, so we can OK that and come out of the form, and then we can switch over to the toolpaths tab, where we can simply recalculate all of the toolpaths, and you can see that all the toolpaths have been successfully recalculated, and now we have 8 individual widgets to cut on our large piece of material, with thanks to the automatic vector selection option that was applied to each of the toolpaths, along with the ability to nest all 18 parts. And so let's just go ahead and preview that just to see what all the toolpaths look like on the one sheet there. Perfect, all looks good. So now we're going to look at one final option in the nesting form, and that's nesting two-sided parts if you're working in a double-sided job. So let's just close out here. We'll go to File, Close. We're not going to save that. So let's go and open an existing file. So from the project folder, we're going to open the two-sided example. We'll go ahead and press open. So here we have a part that requires machining on the top side. So we've got lots of holes here that we would like to apply a drill toolpath to. We've got a cutout pass that's going to use this vector here, and then if we switch over to the bottom side, you'll see that we have these vectors that are dados, and so we'd look at pocketing into those areas. So let's just switch back to the top side and we'll go into the nesting option. And you'll see that in the part nesting options we have this option here, nest two-sided parts, checked, and that's because we are in a two-sided job, and so it'll allow us to nest parts that are on the other side. So we can see that our dados are overlapping the main profile of our shape here. And so if I just drag a box over our selection, you'll see that the software identifies this as a part, so we can see our thick outline, and the software knows that this is one single part, and then these aqua lines represent the parts that are on the other side. Okay, so we've got lots of indication there as to what's on the other side and what the software recognizes as a part. And all we do is the same as before. We could put in a value in here, go ahead and say we want 8 copies, press apply. It's put the number 8 in our part, and then we can preview that and we can see the result of that there. And if we switch to the bottom side, we can see all of those dados have also been nested as well. And so that concludes this tutorial where we've looked at all of the different options to use within the nesting form. Thank you for watching.